Hey everyone, welcome back. We have covered a lot of material so far. You learned about functions and conditional statements and loops. If you didn't catch these videos, you can find them on my DataBit Central channel. Now, we'll learn more about strings. Recall that a string is a sequence of characters and punctuation that contains textual information. This is an immutable data type, which means the values can never be altered or updated. Even though strings are immutable, we can still do a lot with them. For instance, we can concatenate them. To concatenate means to link or join together. So concatenating strings is making a single longer string from two or more shorter ones. To concatenate strings in Python, we simply use the addition operator. If we have two strings, hello and world, we can join them by adding them together. The result is a single string, but it's also a single word. This is because blank spaces, or white spaces, as they're known in computer programming, count as their own characters. If you want a white space between your concatenated strings, one of the strings must contain a white space. Or you must add a third string between them that contains just a white space. The same rules apply when using variables that point to strings. If hello is assigned to greeting1 and world is assigned to greeting2, we can concatenate the strings by adding the two variables. We can also multiple strings using the multiplication operator. Danger times 3 equals danger 3 times. However, we cannot divide or subtract strings. In trying to do so, we'll throw an error. As you know, some characters are reserved for specific purposes when working with strings. For example, quotation marks are used to indicate the beginning and end of strings. But what if we want our string to contain quotation marks? There are two ways we can approach this. The first way takes advantage of the fact that strings can be written with either single quotes or double quotes. If you want to include double quotation marks in your string, use single quotation marks to begin and end your string, and vice versa. The second way is to use the backslash, which functions as an escape character. An escape character changes the typical behavior of the characters that follow it. In this case, the typical behavior of quotation marks is to begin or end the string, but if we precede each with a backslash, they'll behave as regular punctuation marks in the string. The backslash character is useful as an escape character for other special characters in strings too. For example, \n is a special character combination that used to indicate a new line when printing a string. But if you want to include \n as characters in your string when you print it, you must precede the combination with an initial backslash. Moving on, we can also iterate over strings with loops. In this example, we use a for loop to iterate over each letter of the word Python and print the letter plus the letters UT. As a data professional, you'll often work with strings when analyzing data. Let's cover more useful operations that we can perform over strings. First, let's explore a new way to work with strings, slicing. But before you learn about slicing, you'll need some background information about how Python works. As a reminder, an object is iterable if you can sequence through all of its values or items. Indexing is Python's way of letting us refer to individual items within an iterable by their relative position. Indexing is a very important part of Python because it allows us to select, filter, edit, and manipulate data. By the way, indexing isn't just for strings. It also works on many other data types like lists, tuples, and others, as long as they're iterable. Python uses zero-based indexing. That means that the first element of a sequence is indexed at 0. With strings, indexing works by interpreting a string as a sequence of characters, where each character has a numbered slot. If you're reading from left to right, the first character is located at slot 0. The second character is located at slot 1, and the third at slot 2, and so on. Indexing lets us slice strings to create smaller strings or substrings. Here's an example that many data professionals have experience with. A column in a dataset contains employee salary information. In the same field, there'll be both strings and integers, the currency symbol and the salary amount. In this case, Python would automatically interpret the mix of data types as a string data type. This is often a problem because we usually want values that represent money to behave like numbers, so we can perform mathematical operations on them. If they're strings, we can't do that. So, to fix the problem, slicing helps us remove the non-numeric characters, like the $sign, from a string. In this case, we could drop the character at the 0 index of each value in the salary column. This gives us salary information without the currency prefix. Let's explore some ways of working with indices. One useful tool is the index method. Index is a string method that outputs the index number of a character in a string. Remember, a method is a function that applies to a variable. We can call it by following the variable with a dot. We use the index method to identify the location of a character or substring in a string. Here we have a variable called pets, which has been assigned the string cats and dogs. We use the index method by attaching it to the pets variable with a dot. In its parentheses, we enter the character we want the index of. Let's find s. When we run the cell, the computer returns the number 3. This means that index 3 of our string contains the letter s. What if there's more than one of the same character or substring? Here we know that there are 2 ss in cats and dogs, but only one index returns to us, 3. That's because the index method just returns the first position that matches. And if you search for a substring that is not there, say z, you'll get a value error because the substring is not found. Additionally, we can also use an index number to find a specific character in that position. For example, we'll assign the string Jolene to a variable called name. By placing the index number in brackets after the variable, we can access the character at that position. Name at index 0 is J, and name at index 5 is E. What happens if we put 6 instead? We get an index error, indicating that the string index is out of range. You can access the last character of a string even when you don't know how long the string is by using negative indices. Let's consider an example. We don't know the length of this string, but it doesn't matter. Since it isn't super efficient to count each character out, we can reference it by starting from the last position with a negative index. By using the index -1, we get the last character, an exclamation point. And if we use the index -2, we get the second to last character, D. Now that we've gone over the fundamentals of indexing, let's do some slicing. A string slice is a portion of a string. It's also known as a substring. String slices can contain more than one character. Here's an example of how we slice a string of the word orange. Let's start by putting some index numbers inside square brackets and separating the numbers by a colon. This defines the range of characters in a new slice. We'll go from index 1 up to index 4. The closing index is not included in the range that's returned to us, so this would capture indices 1, 2, and 3. And we've extracted a slice that contains the characters that correspond to these indices, R, A, N. We can also use slice notation with just one of the 2 indices. Omitting the first number in the range implies that the range begins at 0. So if the string is pineapple and we indicate our slice using colon for, we'll capture the first 4 letters, pine. Similarly, if we slice using 4 colon, we'll capture everything beginning with index 4 all the way to the end, apple. Sometimes data professionals want to check whether or not a substring is contained in a string. To check whether or not a substring is contained in a string, use the keyword in. Let's find out if banana is in the string contained in our fruit variable. It's false. There is no banana in our pineapple. But is there apple? Let's check. Yes, apple is a substring of pineapple. So the computer returns a value of true. Confirming whether a substring is contained in a string is a common practice in all kinds of data careers. It's important to take some time to go through the steps again on your own. The more you apply what you learn, the more comfortable you will become. Now that you have a foundational understanding of strings, let's learn some new approaches to save time when creating and manipulating strings. Formatting strings using the format method. The format method formats and inserts specific substrings into designated places within a larger string. Let's examine how this appears in code. We have two variables, name and number. The format method uses the curly braces to designate where the variables should be inserted into the string. If we pass the variable names as parameters to the format method, we find that it doesn't matter that the name is a string and the number is an integer. The format method will insert strings of the values represented by these variables. The order that they're inserted in is the order that they're entered as parameters into the format method. In this case, name corresponds to the first set of braces, and number corresponds to the second set. You can also be more explicit with how you designate what substring goes where. You can name your own keywords and insert them into the braces. In this case, we use name and nom. Now, we explicitly assign our variables to those keywords in the method parameters. When we run the cell, the values represented by the variables get inserted into the printed string according to their keywords. Notice that when we do it this way, the order that we enter the method arguments doesn't matter. Name will be inserted into the name field in the string, and number will be inserted into the number field of the string. This approach is very helpful. For example, in cases where an output message needs to be translated into another language. Many languages change the order of words to communicate the same message. This method makes rearranging strings fast and easy. And yet another way to insert values into strings is to use integer values in the braces to indicate the order in which to insert the arguments. Notice how in this example, we can enter the variables number and name in the argument field in a different order than they get inserted into the printed string. As a data professional, these different ways to insert values into strings offer you a lot of flexibility in how you choose to work and solve problems. Here's an example that not only inserts substrings into a larger string, but also formats them. Imagine you want to print the price of an item with and without tax. Depending on the tax rate, the number might extend more than 2 places beyond the decimal. We can use string formatting to set a limit on the number of decimal places in the output, which makes it more readable. In this case, our item costs $7.75 without tax, and the tax rate is 7%. So the price with tax would be $8.2925. To limit the output to 2 places beyond the decimal point, we use special syntax. Start with a colon to separate the expression from the keyword name, if you decide to use one. After the colon, write .2f. .2 refers to 2 places beyond the decimal, and F stand for float. Now, let's check what happens when we run this cell. Nice, the price with tax has 2 decimals now. You can replace the 2 in the expression to any number of places beyond the decimal you want. If you put 0, only a whole number will print. There are even more ways to use the format function to improve expressions. Let's explore our conversion of temperature values from Fahrenheit to Celsius from earlier. At the top is the function we wrote to calculate the conversion. But now instead of just printing the results, we'll format them too. Again, begin with a colon, then use the greater than operator to align the text to the right so that the output is neatly formatted. Greater than 3 will align the output 3 spaces to the right. For the converted Celsius value, we'll use greater than 6, which will align the Celsius temperature 6 spaces to the right. Notice how clean the output is. Our decimals are cut at the hundredths place, and the values output in a nice table. Everything you've been learning about strings will help you work more effectively, streamline processes, and save your company lots of time and resources. Using Python is all about maximizing productivity while minimizing effort, making it the perfect tool to help you achieve these goals. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will learn about arrays and vectors with NumPy, a powerful Python package. Thanks for watching, and see you there.